We have already mentioned that we have two kinds of types in Java. One is the primitive types, and we have talked pretty extensively about each of the primitive types that we see. The primitive types are built into the language. What does that mean? It means that when we write double D, this is all we need to do. We don't need to define what double means. Java understands double and understands int. We can just go ahead and use them. We can just use these types and declare variables that are of those types. When we make such a declaration, for example, int x, what does that mean for the machine that we are running the program? It means that we allocate some memory space. How much memory space? As much as the type says. In the case of an int, we know that we need 4 bytes, 32 bits, in order to store a value that has type int. So when we declare a primitive type variable, we at the same time allocate as much space as is needed to store values that will have that same type. Now, what happens in the case of references, which is the second type category in Java? References can be defined by the user. We have the power to define types. Yes, there are classes that are already built into the Java. They're already declared, already defined in the Java libraries, and we can go and use them in the same way that we use primitive types. We can declare variables that have that type. For example, we can go and say string s. String is not a primitive type, it is a class type, it's a reference type. But in the same way, we can also go ahead and define a class ourselves. We have defined, for instance, the class wheel. When we define a class, we're actually defining a type. And then we can go and declare variables that are of those types. We can say wheel w. That declaration means that w has type wheel. What the declaration of reference types says about the memory allocated? There is a significant difference to primitive types. And what is that? When we declare a variable such as wheel w, we don't allocate as much space as it is needed in memory to allocate a wheel object, a wheel value. We only allocate space for a memory reference, as we say. In other words, we say that the space we allocate will either be 32 bits or 64 bits, depending on the machine that we have, because it will store a memory reference. Let's make that point clear by using a few pictures in the following slides. When we have a primitive type and we make the declaration int x, what happens in memory? In the memory, we just say, please allocate for me as much space as I need in order to store an int value. How much space will that be? We already know. It's going to be 32 bits, 4 bytes. And from now on in our program, we will be referring to that memory space with the name x. This is how we named our int variable. When we go and make the assignment after the variable declaration, x becomes equal to 3. What happens in memory? In memory, the value 3 gets stored into the memory space that we have allocated for variable x. This is the picture, a simplified view of the memory when we are using primitive types. With reference types, the memory picture is a little bit different. Suppose we make the declaration of a reference variable. We have already defined the class person, and then we declare a variable jo having type person. So we write person jo with a semicolon. What does that mean in memory? In memory, the machine is going to go and allocate some space for that variable, for variable Joe. How much space is that going to be? How much memory is that going to take? It is not going to be as much memory as we need in order to store the person value. As many information as we have for the person object. For example, in the person class, we may have defined that a person has a name, which is a string. It also has an address, which may be another string. In order to store those strings, we need some space. This is not space that is allocated when we make the declaration person Joe. When we make this declaration, the machine is going to allocate either 32 bits if it is a 32-bit machine, or 64 bits if it is a 64-bit machine. And why is that? Because in the memory that we have named Joe, the only thing that needs to store is a memory address. What memory address? The memory address where an object of person type is going to be stored later, at some point. When is that later? That later is when we assign a value to the Joe variable. Take a look at the assignment. Joe becomes equal to new person. We have three things here. We have the variable Joe, we have the assignment, Joe, the Joe reference now points somewhere. Where is that somewhere? The statement new person creates a person object, which means that some memory is allocated in order for us to be able to store a person object. That memory is not the same as the memory allocated for the Joe reference when we are declaring the Joe variable. After the assignment, the Joe memory address is going to be referencing the person object that we have just created. And for this reason, what we make graphically as a pointer, as an arrow, in actual terms, the Joe memory cells are going to have inside them a value, an integer value, which is the memory address where the new person object is being stored. Now let's sum up a few things that we said about declarations and reference types. When we declare a variable of reference type, that allocates not space for the object. It only allocates space for the reference. It allocates space in order to be able for us to write down a memory address, not to be able to store an object, a class object. If we never assign a value to that reference variable that we just declared, if we never said Joe becomes equal to something, some object of type person, then the value, the initial value of the Joe variable will be null. And here comes why we get a runtime error called a null pointer exception in cases like the following. Suppose we write wheel w, we declare a variable of type wheel, and then before allocating space for a wheel object, before assigning that object to w, we try to invoke a method of the wheel class through the w reference. This will create a runtime error, a null pointer exception. We will talk about exceptions extensively in a different lecture. But the point here is to understand that we cannot invoke a method through a reference that has not been assigned to an object before.